Now let's talk about exploring those general rules. We'll do that by talking about the many places of a square. Let's start by looking at the definition. The definition of a square is a regular quadrilateral. That means that there are 4 congruent angles, all of them right angles. And that means that we are going to have vertical and horizontal lines. We also have 4 congruent sides, which means that all of the coordinates are going to be related to each other. Whenever you have congruent sides, you have related coordinates. And most people place a square using the origin and the 2 axes. That makes complete sense. Then if we take a look at one of the coordinates, say the lower right one there, if we call that A0, then the upper left one has to have the same length. Its x-coordinate will be 0, so its y-coordinate has to be A. That way, both sides have the same length of A. And now if we look at the upper right vertex, its coordinates are A, A. The x-coordinate comes from going directly up from A0, and the y-coordinate comes from going horizontally over from 0A. Nice beautiful square. Because all these coordinates use the variable A, it guarantees that we have congruent sides. But wait, that's not all. This is wonderful if we're talking about the sides of a square. But what if we're talking about midpoints? This is all fine and wonderful, but there's a way to set midpoints up on squares that doesn't require us to use the number 2. And that is to center the square around the origin. The right angles make these midpoints very cool. So this will also work on rectangles. And something similar will work with isosceles triangles as well. Let's take a look at the coordinates for the 4 vertices. Notice that by using A's, we guarantee that all of the sides have the same length. Obviously, when the vertices are not in the first quadrant, we get some negative numbers, but that's okay. So let's take a look at that top midpoint. Obviously, the y-coordinate is going to be A because we're staying up at the A level. But what is halfway between the opposite of A and A? 0. And so if we look at all of the midpoints, notice that 0 becomes a coordinate in all of the midpoints. And every single one of our coordinates that is not 0 is an A. This way we can even avoid using the number 2, making things so much easier. But wait, this is not all. What if you wanted to work with the diagonals? In a situation like that, it might actually be easier to rotate the square. Now notice what the diagonals are. They become the x and y axes. And this is another property of squares that are really cool. Okay, this works with all rhombi, not just squares. When you're working with rhombi, it's not only when you want to work with diagonals. This is the best placement for rhombi that are not squares. Okay, it's so much easier to get the congruent sides in a rhombus if you rotate it so the diagonals are the axes. This also works with an isosceles triangle if you're talking about the altitude. Now let's take a look at the vertices of our square. Once again, notice how everything's either an A or the opposite of A and a 0. And what makes this nice is where do the diagonals intersect? At the point 0, 0. So knowing what you're looking for within a problem can help you determine where to put your figure.